Hello everyone, my name is Carlo and I would like to present you my final project called Cerro Viejo, 10 Years of Protection. Where is the forest now? This is a study where I analyze forest cover change when a natural protected area called Cerro Viejo was legally established in 2013, and I compare it 10 years after in 2023. So in 2013, the Jalisco state government decreed the creation of the Cerro Viejo, Chupinaya, Los Sabinos, natural protected area in western Mexico. This is an area that it's important because of hydrological protection and hydrological recharge to aquifers and to two lakes that are nearby, which is Lake Chapala, Mexico's biggest lake, and Lake Ajititlan. This natural protected area has an area of 23,176 hectares, and they are located between four municipalities, which are Jocotepec, Chapala, Tlajumulco, and Ixtlahuacan. This area is important also because it's a hotspot in terms of biodiversity. In the region, there are records of more than 360 species of resident and migratory birds. And also it has 21 species of medium and large mammals like cougars, bobcats. Also, the area is important in terms of the cultural heritage because people use the area for hiking, wildlife observation, naturalists, and also there are a lot of expressions of faith related with Christianism in the area. So now, when we analyze the land cover by type of vegetation or type of use cover, we can see that most of it is coniferous forest, oak forest, low deciduous forest, some barren land, and agriculture land. So let's learn a little bit more about each type of vegetation that we can find in the area. The most important vegetation because of its surface is the oak forest. Oak forest covers around 71% of the entire natural protected area. Usually this type of forest has a mix between oak species and pine species. The forest has or grows in low, medium to highlands, and with temperatures that are temperate and semi-humid climates. The trees range in height. It's between 2 meters to 30 meters. Some of the oaks lose their leaves during the dry season, but other species remain green through the entire year. The other type of vegetation that has important surface in the area, it's the low deciduous forest with around 9.4% of the entire area. This type of vegetation, it's really interesting because during the dry season, it loses its leaf. Dry season occurs between winter and spring. But during the raining season, which is summer and part of the fall, it recovers and it turns out green. Trees are smaller. They are between 8 to 12 meters in height. And of course, agriculture land, it's important also. It has 50% of the entire surface of the natural protected area. This region, it's really important to berries production. It's the main producer in Mexico. So you would find a lot of greenhouses like the ones in the pictures covering the entire area, the valleys mainly. But also in the hillsides, people grow only during the rainy season, corn, beans, chili, and squash. So, well, Now, what we did to analyze the forest cover change in this period of 10 years, we download Landsat 8 satellite image. We download one image from 2013, and we download another one from 2023. Both of them were from the month of December, when we usually found minimal cloud cover. And then we perform a supervised classification where we classed the land cover in the following classes: forest cover, bare soil or grassland, greenhouse agriculture or agriculture, and urban areas. Once we classify the land use, we perform some geoprocessing operations. For example, we use the solve tools to remove boundaries between adjacent polygons that have the same type of land use. And then we use the interpolation tool, which allow us to compare the changes through the 10-year period. Now, our results are mainly three maps. The first one is the forest cover lost. By comparing the classified image from the 10-year period, we found out that 2,682 hectares of forest were lost. Some of them were converted into grasslands, others were deforested or turned into agricultural areas or urban areas. But it's really interesting to highlight that the places where we lost forests are mainly in the lower parts of the mountains, which are the areas that are closer to urban populations. So I guess there might be a correlation between how close they are to human or urban centers and the forest lost. And then another one was how much forest did we gain in this 10 years. So from our results, we found out that 2,682 hectares were gained in terms of forest coverage. But here, it's the opposite of the forest lost. And as we can see in the maps, the forest gain occurred on the upper parts of the mountains, on the tops mainly. And we suppose that it's because they have less human pressure up the mountain. So that allows them to grow easily and faster compared to other areas where they might have pressure in terms of people logging or cattle grazing. And now the final map, it's a combination between the two maps. It's an overlap of the two forest cover gain and lost. And well, here's what we can see. Where are the areas where we went or gained forest and where we lost forest. I mean, we don't know the causes behind the forest lost. We suppose it can be logging, cattle grazing, for cattle grazing, or maybe also fires, but that could be another idea to explore. And I would like to mention some limitations I found out carrying this study. The first one is that supervised classification requires that we have data from areas we are completely certain that it has the type of cover we classified. For example, that we are really sure that the classification of oak forest is really in the land in the field forest or oak forest. So what I did was to do the training sites with Google Earth, like looking at the satellites and trying to find what was forest and what was barren land or pastures. So yeah, that would be one of the limitations. And the other one is that because of the training, I could not do a subclassification in terms of the type of forest we were losing or gaining. For example, oak forest, low deciduous forest, coniferous forest. But well, that's at the end we don't know which type of forest we are losing because in the map we can see that our what we lost is a forest that it's on the boundaries of the area, and usually the lowlands of the mountains, it's where low deciduous forest grows. So probably it could be this type of vegetation that we are losing, and not and the areas that we are gaining forest would be oak forest or coniferous forest. So yeah, this is my project. I hope you like it, and if you have any question, don't hesitate to contact me. And thank you very much for your attention.